Okay, so Chapter 6, Lesson 6 is the distributive property. I think you're going to enjoy this one. So list two headings you would use to make an outline of the lesson. So we're going to learn what distributive property is and how to use it, bless you. And we are going to learn how to factor an expression. Now here in the real world link, we're just going to do that first part up here. It says 3 friends went to a baseball game. Each ticket cost $20, and all 3 friends bought a baseball hat for $15. So it says, what does the expression 3 times a quantity of 20 plus 15 represent? Well, here the 3 represents how many friends went to the baseball game, right? The 20 and the 15 represent the tickets, the 3 tickets they bought, right? They bought 3 tickets, and they bought hats for $15, right? So that's $20 tickets and $15 hats. Now, here, if I want to evaluate this, I can add 20 plus 15, that gives me 35, right? Yeah. And then I'm going to multiply that times 3, and then that gives me 105. Is everybody with me? Yep. All right. Now, using the distributive property, we can simplify this another way, okay? We can say, let's see. Let me go back up to this. We can say 3 friends bought 3 tickets, right? How much were the tickets? $20, right? So how much did that cost? $60. So we did 3 times 20, right? 3 times 20, that gives me 60. Is everybody with me? Yep. Then I said those three friends bought hats for $15. So how much money did they spend? No, how much money did they spend on the hats? $45. 15 and 3 of them bought, right? So that's $45. So if I add the 60 for the tickets that they all spent and the 45 for the hats, we get $105. Does everybody see that? So there's 2 different ways you can simplify that, and today we're going to learn the second way. The first way was the order of operations. All right, so the distributive property. To multiply a sum by a number, you're going to multiply each addend by the number on the outside of the parentheses. Now remember, the addend are the numbers you're adding, right? So in this first example, the addends are 7 and 4, okay? And the number on the outside is what's getting multiplied times everything on the inside of the parentheses. So this is what you're going to write down. You're going to write down the definition of the distributive property. You're going to write this definition of the distributive property, and you're going to write your 2 examples. Okay? Please make sure that you title this the distributive property. All right, so in the first example, we have 2 times a quantity, 7 plus 4. Okay, with the distributive property, you're going to take that 2 that's on the outside, and you're going to multiply it times everything on the inside. So here you have 2 times 7. That gives me 14. Then I have 2 times 4. That gives me 8. And then, to simplify further, I would add the 14 plus the 8. Is that clear? Yeah. All right. And then over here, that's what it looks like algebraically with just variables. So here, you're just going to take the A and multiply it times everything on the inside of the parentheses. So the distributive property combines addition and multiplication in simplifying our expressions. So for example 1, it says find 9 times 4 and 1/3 mentally. Okay? So here we're going to use the distributive property. So we've got 9 times 4 and 1/3. Now, how can I write 4 and 1/3 using an addition problem? We know we can just separate the whole number and the fraction part, right? We just separate the whole number and the fraction part. So the whole number is 4. The fraction part is 1/3. If I add them together, I get 4 1/3, right? So when we're showing you this using a distributive property, we're just going to separate the whole number and the fraction part. You got that? So we end up with 9 times 4 plus 1/3. Now watch this. Using the distributive property, we're going to take the number on the outside and multiply it times everything on the inside. So what's 9 times 4? 36. Then what's 9 times 1/3? What is it? 3. Does everybody see that? If I have 9 times 1/3, can't I simplify this? 3 divided by 3, 1. 9 divided by 3, 3. And you multiply straight across, you end up with 3 over 1, which is just 3. Does everybody see how that works? So 36 plus 3 is equal to 39. All right, so 5 times 2 and 3/5. So 5 times, now the 2 and 3/5, we're going to separate that to the whole number and the fraction part, right? So it's going to be 2 plus 3/5. So we've got 2 plus 3/5. Okay? Now, using my distributive property, pay attention. Using my distributive property, now I can multiply the number on the outside, the 5, times everything on the inside. So what's 5 times 2? 10. Plus, what's 5 times 3/5? 3. Because remember the 5 and the 5 will cancel, right? So here, 10 plus 3 is 13. So we have 12 times 2 and 1/4. 12 times 2 and 1/4. So the 12 is going to multiply, we're going to multiply that 12 times something in my parentheses. Now, we've got 2 and 1/4. We're going to separate the whole number and the fraction. You with me? So 2 and 1/4 is going to be 2 plus 1/4. Okay, good. So 2 plus 1/4. Okay, so now we're going to use the distributive property to simplify. So that 12 gets multiplied times each of the addends in the parentheses. So 12 times 2 is 24. Plus 12 times 1/4. Think about it. Think about it. 3 times. So 12 times 1/4. 3. Because remember, multiplying times 1/4 is the same thing as dividing by 4. So 24 plus 3 is? 47. Very good. Now, did you guys need to see how that 12 times 1/4? So for the last example, we have 2 times 3 and 6/10. 3.6. So it's going to be 2 times, how am I going to separate the 3.6? 3 plus the 6/10, right? So it's going to be the decimal. So we're going to put 3 plus 0.6. Is that clear? So now you're going to take that 2 and multiply it times everything on the inside. Okay? You guys, if you need to do the arrows like this, okay, you can do that too. Okay? So here we've got 2 times 3, which is 6 plus 2 times 6/10, which is, or 0.6, 6/10, which is what? Well, what's 6 times 2? 12. So this is going to be 1.2. Okay. 1.2. And then 6 plus 1.2 is equal to? Very good. 10.2. So now we're going to use the distributive property to rewrite 2 times the quantity x plus 3. Okay? So 2 times x plus 3. That means we have an x plus 3 twice, right? So does everybody see this picture? Yep. Here, that is, there's 2 x's, and there's the x. I mean, those are the 1, 2, 3, right? There's the x and the 1, 2, 3. We have 2 of them. So how many x's do I have? 2x. There's my 2x, right? And how many whole numbers do I have? 6. And there's my 6. Is everybody clear?
Yes.
I know. All right. So once again, you're going to use the distributive property. Here, I don't want you, you're not going to have to draw pictures like you saw in the example. All you're going to have to do is show the work. So here, write your original problem. 8 times a quantity, x plus 3. Write your original problem. So now, we're going to take the number on the outside, right, and multiply it times everything on the inside. And once again, you guys, if you need to draw your arrows, to remind you what you're multiplying, draw your arrows, okay? So here, 8 times x is equal to 8x. And 8 times 3 is equal to 24. So this is going to be plus 24. Is everybody clear with that?
Yeah.
Do you want me to put the step in the middle where it says 8 times x and then 8 times 3?
No.
All right. If you need to show this extra step in the middle there, go ahead and do it. Okay? If you can just follow your arrows and go straight to the 8x plus 24, that's fine. Okay? All right. Oh, here the x is in the back. Does that make a difference?
No.
No. You're still going to just take that number on the outside and multiply it times everything on the inside. Okay? So the 5 gets multiplied. We multiply the 9, and we all multiply 5 times the x. So 5 times 9 is 45. Plus 5 times x is 5x. And there's your final answer. Simple?
Yeah.
All right. Now the last one, just to round this out, we're going to take the 2 and multiply it times the x and times the 3. You writing this down? So 2 times x is 2x. Plus 2 times 3 is 6. And that's your final answer. All right, so Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4.5 centimeters of wire, and each bracelet uses 13 centimeters. We're going to write 2 equivalent expressions and then find how much total wire is needed. So we can say, how much wire does she need for the bracelet, and how much does she need for the earrings? So how much does she need for the earrings? 4.5 centimeters, right? 4.5 centimeters of wire, right? And how much does she need for the bracelets? 13. So that's for one set of jewelry, right? But how many sets of jewelry is she going to make? 4, because she's making it for 4 of her friends, right? So that means we have to add those 2, so 4.5 and the 13, right? We multiply it times 4. So here it is right here. the 4 times 4.5 plus 13. Then, to use the distributive property, we're going to take that 4 times 4.5 over here, right? And then we're going to add 4 times 13 right here. So that's 18 plus 52, which gives me 70 centimeters of wire. Is everybody clear? Let's do one together. So here, each day Martin lifts weights for 10 minutes and runs on the treadmill for 25 minutes. Write 2 equivalent expressions and then find the total minutes that Martin exercises in 7 days. Okay? So, how much does he exercise in one day? We're going to add, what are we going to add? We're going to add the 25 and the 10, right? Okay, so we've got 10 minutes lifting weights plus 25 minutes on the treadmill. That's for one day. But we want to know how many minutes he exercises in 7 days. So that gets multiplied times 7. Very good. And there is our expression that we're going to simplify using the distributive property. Is everybody clear with that?
Yes.
So, we are going to take that 7 and distribute it throughout the parentheses. That's why they call it the distributive property. So, 7 times 10 is 70, plus 7 times 25 is 175. We should be writing this down. And when we add that together, what do we get?
245.
Very good. 245 what? Minutes.
Minutes.
Good. 245 minutes exercising in 7 days. All right. So now we're going to factor an expression. Okay. Does that look familiar to you? Right? The prime factorization using our factor trees, right? Now we're going to try to do them in our head. So when numeric or algebraic expressions are written as a product of their factors, the process is called factoring the expression. Okay. So here we are going to factor 12 plus 8. So we want the prime factors of 12. 2 times 2, that's 4, times 3, right? So 2 times 2 times 3. 8 is 2 times 2 times 2. Now we're going to see what do they have in common. They have the 2's in common. So 2 times 2 is equal to 4. That's the greatest common factor that is going to come out into the parentheses. Okay? So here, the 4 goes out to the front of the parentheses. And what's left here? The 3 and the 2. So now we're going to add 3 plus 2. So here is the expression that we're looking for. 4 times the quantity of 3 plus 2. Is everybody clear with that? Let's do some together. Okay? That was the answer. 4 times 3 plus 2. Because they're just asking you to, what are they asking you to do? Where is it? Write each term as a product of a GCF, and we are just factoring the sum. Okay? So here we have 9 plus 21. We have 9 plus 21, right? So, for 9, the prime factors are 3 times 3. 3 times 3. For 21, the factors are 3 times 7. Okay. I just like to do them in order, right? Okay. So, what do they have in common? They have the 3's in common, right? They have the 3's in common. So that greatest common factor is what's going to come outside of the parentheses. So we have 3 on the outside, and what are we left with for the inside? 3 and 7. So that's going to be 3 plus 7. Is everybody clear? All right. Now, so we can do the factoring also with variables. So here we have 16 plus 4x. For 16, when we break that into the factors, that's going to be 2 times 2 times 2 times 2. Does everybody see that? 4 times 4 is 16, right? For 4x, we're going to break that down to 2 times 2 times x. Is everybody with me? What do we have in common? A 2 here and a 2 there. So what's going to come outside of the parentheses? 2 times 2, which is 4. So that's on the outside. And what's left? 2 times 2 plus x. So we want to factor 14 plus 28. So now 14, when we break that down to the prime factors, it would be 7 times 2. I'm going to put it in order, 2 times 7. And then for 28, that's 4 times 7, right?
Yeah.
But the 4 can be broken down to 2 times 2. So this will be 2 times 2 times 7. Is everybody with me? Now we want to see what they have in common. So here they've got a 2 and a 7. So what is the GCF that I'm going to be factoring out to put on the outside of the parentheses? 2 times 7, which is 14.
All we needed was times.
So, that's 2 times 7. That's the GCF. That's going to go on the outside of the parentheses. So that's going to be 14. Now we need to see what is left. Well, I have a 2 here. I got nothing up here. I got to have something though, right? You got to have something so you can add it. So, thank you. Because if you multiply here times 1, does it change anything up there?
No.
No. So now, what you're going to put inside your parentheses is 1 plus 2. All right. So, these are big numbers. Okay. So, I might have to just do the factor trees on the side. Okay? So, here we have 80. Let's see, we have 8 times 10, right? 8 times 10. That can be broken down to
4 times 2.
4 times 2. And over here, this can be broken down to, right, 2 times 5. And then that 4 can be broken down to 2 times 2. And then we can just bring everything else down. You got it? So 80 is 2 times 2 times 2 times 2, 1, 2, 3, 4, times 5. Okay? And then we have to do 56. 56, 7 times 8, right? So let's see, 7 times 8, that one's prime. The 8 can be broken down to 2 times 4.
4 can be broken down to 2 times 2.
Good, and then we'll bring these down. So 56 is 2 times 2 times 2 times 7. Very good. So now we're going to circle what they have in common. So we've got 2 times 2 times 2. Anything else? No. So we've got 2 times 2 times 2 is 8. And then what's left inside my parentheses to add? 2 times 5 is 10 plus 7. You can also factor with variables involved, right? So here we have 3x plus 15, 3x plus 15, and then you can factor it out. So the 3x is broken down to 3 times x. The 15 is broken down to 3 times 5, right? Then what they have in common is the 3. That's what's going to get factored out. So here's the 3, and what's left is the x plus 5. You got it?
Yeah.
So let's do one. Letter L. So we have 7x. So the 7x, we're going to factor each of these. So 7x can be broken down to 7 times x, right? The 42, 6 times 7 is 42, right?
Yeah.
And then the 6 can be broken down to
3
2 times 3. So we've got 2 times 3 times 7, right? So now what do they have in common?
7.
They have the 7s in common, right? So the 7 is the GCF. It's going to be factored out and placed on the outside of the parentheses. So that's going to be 7 on the outside. And what's left on the inside?
6 plus F.
X on the top, right? So that's going to be something. Plus
6.
6. 2 times 3. Is everybody clear?
Yeah.